CERN, the most advanced scientific research center in the world, is at the heart of some of the most groundbreaking discoveries in modern history. But what if I told you that something much more sinister is happening behind the closed doors of the Large Hadron Collider? Today, we're diving into the shocking claims made by none other than David Icke, who believes that the experiments at CERN aren't just pushing the boundaries of science, but are also putting each one of us at risk. Get ready, because what you're about to hear might just change the way you see the world forever. But before we begin, make sure to like and subscribe to the channel. CERN is known for its mission to unravel the secrets of the universe. From the discovery of the Higgs boson to the study of the very structure of space and time, the research conducted there is nothing short of revolutionary. But with great power comes great responsibility, or in this case, great risk. The European Organization for Nuclear Research, widely known by its French acronym CERN, has been famous for its bold experiments since its founding in the mid-1950s. Due to its groundbreaking work, the organization has garnered considerable attention over the years, both positive and negative. However, some of its experiments have raised concerns about the risks involved, such as the possible creation of black holes or the alteration of reality. One of CERN's most famous and controversial projects was the construction of the Large Hadron Collider, which became operational on September 10, 2008. This colossal machine, stretching over 17 miles, 27 kilometers, and equipped with powerful superconducting magnets, is the largest particle accelerator in the world. It uses a series of accelerating devices to propel particles to incredibly high energies as they pass through its circuits. Despite its hefty price tag of over $45 billion, many argue that the investment was worth it. After all, the collider has yielded some of the most innovative discoveries of recent times, including the identification of the Higgs boson and numerous other previously unknown particles. Imagine this gigantic machine launching particles around its immense circuit, pushing them to speeds close to the speed of light, making over 11,000 revolutions per second. It's a marvel of human ingenuity and engineering, opening doors to areas of knowledge that were previously inaccessible. The collider uses a series of powerful electromagnets to create a magnetic field in the accelerator that is nearly 1,000 times stronger than the Earth's magnetic field. Some worry about how this intense magnetic field could affect nearby electronic devices, or even the Earth's magnetic field. When the particles reach their maximum speed, nearly 1,000,000 times the speed of light, they collide, producing an explosion of energy and several smaller particles. These collisions are brief, with most particles disappearing in just fractions of a second. Scientists use specialized detectors placed around the collision points to capture every detail of these fleeting events. Sorting through the enormous amount of data generated by these collisions, more than 15 petabytes a year, takes considerable time and effort. In 2017, the collider reached a significant milestone by storing over 200 petabytes of data, equivalent to about 250,000 movies. But amid all this data, what exactly are the researchers hoping to discover? One example was when scientists noticed something unusual happening with a specific type of quark. Quarks are tiny particles that make up everything around us. There are different types, like flavors of ice cream. Some of these flavors are quite unstable, quickly transforming into other particles. The B quark, which lasts for an incredibly short time, just a fraction of a second, caught their attention. Normally, when a B quark breaks down, it should transform into lighter particles called leptons, more specifically an electron or a muon. Scientists thought the chance of it becoming one or the other was equal, 50% for each. But the data from the Large Hadron Collider showed something unexpected. These quarks were turning into muons about 70% of the time, not evenly between muons and electrons. This difference suggests there might be some hidden element in the process, perhaps a mysterious particle scientists have never seen before. It's like finding an extra piece in a puzzle you thought you had already solved. With this, some experts began to wonder if this could mean that there's a completely different set of rules in play regarding how particles interact, shaking up what they know as the standard model of physics. It's an intriguing possibility that could answer many questions about the universe that have remained unanswered for a long time. The idea of finding new physics goes beyond what they currently understand as the standard model of physics. This model is like a map that explains how tiny particles behave in our world. It's impressive because it covers practically everything we know about the smallest particles that make up nature. Even though it's so precise, scientists still think it's incomplete. The standard model talks about three main forces: electromagnetism, the strong force, and the weak force. But it doesn't say anything about gravity or dark matter, a mysterious substance that makes up most of the universe. During some recent experiments, scientists noticed something strange in their data. It didn't match what the standard model predicts. It's not uncommon to see odd results from time to time, especially with the amount of data that comes from experiments like those at the Large Hadron Collider. But this time, scientists got curious and began studying further to find out what was going on. They wondered if maybe some unknown force was showing up in their experiments. They gave this phenomenon the name Z prime, which could be a new type of particle. Even though this force might be super weak, as they hadn't seen any signs of it before, it could still explain this unexpected discovery. Researchers think this new force would behave differently when interacting with electrons and muons, but they're not sure how it would interact with the common particles they already know. If scientists find new particles carrying this force, it would be a major breakthrough in physics. They believe that if they confirm this discovery, it could help solve big mysteries about space and explain problems that have remained unsolved for centuries, like dark matter and the role of the Higgs boson. Some scientists believe this new force could help understand very important parts of physics, reorganizing all the basic forces that make up nature. According to Elon Musk, CERN built the largest and most powerful particle collider in history, the Large Hadron Collider, constructed between 1998 and 2008 with the help of over 10,000 scientists and numerous institutions and laboratories from over 100 countries. It is located 574 feet, 175 meters below ground, inside a 17-mile, 27-kilometer tunnel that crosses the border between France and Switzerland, near Geneva. The first collision observed at the Large Hadron Collider was super powerful, with an energy of 3.5 tera-electron volts per beam, about 4 times stronger than the previous record. After some improvements were implemented, this energy level shot up even further, reaching an impressive 6.5 tera-electron volts per beam, as pointed out by Musk. This colossal machine specializes in smashing proton beams with remarkable precision. It also has the capability to boost lead-ion beams, a feat performed annually during a month-long period dedicated to this specific experiment. During these sessions, scientists carefully examine numerous particle physics hypotheses with the goal of validating or refuting their predictions. At the heart of the collider's mission is the quest to unravel the mysterious nature of the Higgs boson and discover a multitude of new particles predicted by subatomic theories. Hadrons, which are the building blocks of matter on this scale, are complex entities composed of various quarks bound by a powerful force similar to the one that holds atoms and molecules together. Hadrons include more well-known particles, such as protons and neutrons, as well as less famous particles, like pions and kaons, whose existence was revealed through experiments with cosmic rays in the mid-20th century. The Large Hadron Collider simulates a massive cosmic collision by converging 2 streams of opposing particles, facilitating the exploration of the mysterious Higgs boson. This boson, an elementary foundation woven into the Higgs field, manifests as a ripple in the quantum sea, much like waves do in the ocean. It represents a new addition to the ever-expanding catalog of particle physics. The Higgs boson is different from ordinary matter and lacks the quantum properties typical of carriers of fundamental forces such as electromagnetism, the weak force, and nuclear interactions. The Higgs boson was discovered at the Large Hadron Collider. This historic achievement occurred simultaneously during experiments conducted by 2 large teams, ATLAS and CMS. The revelation was made public on July 4, 2012 at CERN. Initially, the Higgs boson was detected through 2 exceptionally rare decay channels that provided the easiest signals to detect. In these decay channels, particles were observed disintegrating into pairs of photons, a process entirely governed by quantum mechanics, and transforming directly into a pair of Z bosons, which are particles responsible for one of nature's fundamental forces. However, the discovery of the Higgs boson did not mark the end of scientific investigation. On the contrary, it triggered even more research. Since 2012, one of the most significant developments has been the confirmation of how the Higgs boson decays. CERN, which has been at the forefront of this research, indicates that studies on this elusive particle will intensify during the 3rd operational phase of the collider. This phase will be powered by a high-luminosity upgrade expected to be completed by 2029. This upgrade will enable the Large Hadron Collider to perform more collisions, giving scientists enhanced opportunities to discover events that defy the predictions of the standard model of particle physics. CERN predicts that once upgraded, the collider will produce an astounding 15 million Higgs bosons annually, a substantial increase from the 3 million produced in 2017. This increase in production could be invaluable in distinguishing the various different manifestations of the Higgs boson. Theories beyond the standard model of physics speculate about the existence of up to 5 distinct forms of Higgs bosons, some of which may appear far less frequently than others. But why all the talk about the Higgs boson? The Higgs field is crucial, especially for understanding the early days after the universe began. It determines how space forms, creating the vacuum where everything exists. Without it, there would be no matter or the substances that make everything work together. And we wouldn't have mass in the tiny components that make up the universe. If the Higgs field and its particle, the Higgs boson, didn't exist, we wouldn't have any of the basic things that form atoms, stars, or even life itself. People started calling the Higgs boson the God particle because it was so hard to find. The name became popular thanks to the media, but originally, the name came from when a scientist named Leon Lederman made a joke by saying the boson was a goddamn particle because it was so difficult to detect. When he wrote a book about it, that's how he described the Higgs boson, but his editors changed his words to God particle. This created some friction between science and religion, but regardless of all that, the Higgs boson and its field are crucial. Without them, nothing would have mass, and that means there would be no stars, planets, or even us, human beings. Scientists are deeply investigating the mysteries of the Higgs boson for 2 main reasons. First, they are eager to discover the origins of the physical vacuum that surrounds our universe, which dates back to the early stages of the cosmos. And second, they are interested in understanding how this vacuum can maintain its stability over time. The Higgs field possesses a peculiar property. It carries a constant potential energy that influences the physical vacuum. This unique characteristic plays a fundamental role in giving the universe the structure we know. Scientists believe that understanding and capturing this potential energy could explain fundamental forces like electromagnetism, which extends infinitely, and the weak force, which acts over extremely short distances. To unlock these secrets, scientists need to understand how Higgs bosons interact with one another. This involves creating pairs of these elusive particles. Although the Higgs boson has already provided valuable insights into how other particles acquire mass, its own mass remains a mystery. Theoretical symmetries fail to reliably describe its mass, leading to potential instabilities that could disrupt the physical vacuum through quantum fluctuations. Fortunately, the timescale for these disturbances exceeds the estimated lifespan of the universe. But the search continues. Scientists are on the lookout for other similar particles that could signal new physical discoveries crucial to stabilizing the Higgs boson's mass. This search calls for even more extensive data analysis and, if possible, access to even more powerful energy colliders. Because of this, a decade later, hundreds of dedicated experts around the world remain committed to unraveling these mysteries. The Higgs boson was first proposed in 1964 and finally discovered in 2012. It has fascinated science enthusiasts because of the long delay in proving its existence. The reason behind this delay lies in the boson's hefty mass and its extremely brief existence. To produce such a massive particle, scientists had to cram huge amounts of energy into a tiny space, requiring the use of high-energy colliders. Once formed, Higgs particles quickly decay into various fragments, with only a fraction being distinguishable from the background noise. To capture these fleeting particles, scientists built giant and complex detectors that analyze billions upon billions of proton collisions, searching for the characteristic signals of the Higgs boson. But even with so much attention around CERN's discoveries, several conspiracy theories have emerged. Some people make grim speculations about CERN's true intentions, suggesting that its experiments are a gateway to the realms of hell. They fear that by manipulating subatomic particles at such high speeds, CERN could unintentionally unleash forces beyond our understanding, leading humanity into a cataclysmic abyss. However, CERN vehemently refutes these claims, stating that its search for antimatter is aimed at deepening our understanding of the universe, not summoning demons. Antimatter, characterized by particles with opposite electrical charges to conventional matter, holds significant importance in cosmological theories such as the Big Bang, where it is believed to have played a key role in the creation of the universe. Far from precipitating catastrophe, CERN's research efforts seek to illuminate the mysteries of existence, bringing us closer to uncovering the universe's secrets. Antimatter, although rare, holds a special place in scientific curiosity. At CERN, the largest particle physics laboratory in the world, another interesting idea has caught attention: the Mandela effect. This phenomenon describes how collective memory can differ from actual events. Some theorize that experiments at CERN might be disrupting our perception of reality, potentially sending us into parallel dimensions and causing widespread anomalies in our memories, something akin to the Mandela effect. Additionally, there are rumors among conspiracy theorists about sinister activities allegedly taking place at CERN's facilities, including claims of human sacrifices. A leaked video in 2016 showed hooded figures involved in a ritual with chilling scenes of a child being harmed. However, CERN quickly denied these claims, stating that the video was a prank staged as a joke. Whether authorities investigated this further remains uncertain. Given its cutting-edge research and the aura of mystery surrounding its underground facilities, CERN naturally attracts conspiracy theories. When scientists resumed activities after extensive upgrades in July 2022, speculation on the internet increased even more. However, amidst all the sensationalism, it's crucial to note that CERN's research is firmly grounded in science, not apocalyptic prophecies. Instead of opening portals to other dimensions, CERN's experiments delve into the fundamental mysteries of the universe, offering glimpses into realms of physics previously unknown. The phaser experiment conducted at the Large Hadron Collider made a surprising discovery. For the first time, high-energy neutrinos created by a particle collider were detected. With remarkable precision, this experiment identified 153 neutrino interactions, marking a significant achievement in particle physics. This discovery opened the door to a deeper understanding of the intense interactions between neutrinos and shed light on the mysterious processes of stellar nucleosynthesis and supernova explosions. As scientists anticipate the next revelations to emerge from CERN, it's important to recognize the profound impact this organization has had on our understanding of the universe. From the discovery of the Higgs boson to the identification of neutrinos that are incredibly difficult to detect, CERN's experiments confidently push the boundaries of human knowledge and challenge the most basic laws of physics. However, CERN's pursuit of knowledge has not been without controversy. Some fear apocalyptic consequences or suspect sinister activities associated with its experiments. Despite these concerns, official statements and explanations debunking conspiracy theories are among the responses highlighting the organization's commitment to promoting the scientific understanding of the universe for the benefit of humanity. Indeed, CERN's efforts not only expand cosmic understanding, but also drive technological innovation and inspire future generations of scientists who ponder the limitless potential of the future. The next discoveries from CERN promise to change the way we see the universe. Whether uncovering the secrets of dark matter, investigating the nature of space-time, or understanding the basic forces of physics, CERN is always breaking new ground. Future generations of scientists eagerly await what CERN will reveal next, celebrating its incredible achievements and how the institution has expanded our knowledge of the universe. Who knows what other groundbreaking discoveries await us as we explore the cosmos alongside CERN? It's an exciting journey, filled with the thrill of uncovering new knowledge and pushing the boundaries of what was thought possible. With every experiment at CERN, scientists come closer to unraveling the universe's secrets and gaining a deeper understanding of reality itself. The complex workings of the Large Hadron Collider and the careful analysis of data by researchers have paved the way for revelations that could change everything we know about the universe. Moreover, CERN's adventurous spirit shines like a beacon, inspiring scientists, educators, and science enthusiasts all over the world. This approach emphasizes the importance of pursuing knowledge out of sheer curiosity, reaching new understandings for the good of humanity. Neutrinos, those tiny subatomic particles, are everywhere. They're generated by atomic processes like nuclear reactions, cosmic rays, and even the radioactivity of potassium and bananas. But despite their abundance, they remain difficult to detect, earning them the nickname ghost particles. Since their first detection in 1956, scientists have been trying tirelessly to observe these particles. In 2021, physicists detected traces of 6 neutrinos, but it took another 2 years to definitively confirm their existence. According to Jamie Boyd, A particle physicist at CERN, studying these ghostly particles may give us unique information about deep space that other methods do not offer. The search for neutrinos at the Large Hadron Collider is crucial for advancing particle astrophysics. With data collection continuing until 2025, scientists anticipate discovering more of these ghostly neutrinos and unveiling other unexplored mysteries of physics. The excitement builds as the scientific community eagerly awaits CERN's next revelations and contemplates their implications for the future of science. What do you think about CERN's discoveries that continue to shock scientists around the world? Leave your opinion in the comments below. If you enjoyed it, don't forget to like and subscribe to the channel. Thanks for watching, and see you next time.